Okay, in solving an application problem, let's first take a second and read it. So we've got a movie theater that sells tickets for $8 each, with seniors receiving a discount of $2 each. I'm going to pause for a second. So how much are seniors now paying? That'd be 6. So they get a discount of 2, so 8 minus 2 is 6. One evening, the theater sold 525 tickets and took in $3,580 in revenue. How many of each type were sold? Okay, so our first task, step 1, is to identify any unknowns, or in other words, variables. What are we actually solving for in this? So it says how many of each type were sold. So we'll say that X is the number of $8 tickets, and Y is going to be the number of $6 tickets. Number of people pay full price versus number of people pay discounts. Okay, so then step 2, we're going to look at each sentence and write down any equation that relates the variables. In other words, take a look at the sentences and see what equation we can write in terms of X and Y. So in that first sentence, where we're told that there's $8 tickets and essentially $6 tickets, not much of a relationship we can write with X and Y there, aside from figuring out that it was $6. The second sentence was a little more interesting. It says one evening the theater sold 525 tickets. So if I take the number of $8 tickets and I add it to the number of $6 tickets, I should get how many tickets were sold. And then the second part of that sentence says they took in $3,580. So if I take $8 times the number of $8 tickets and then $6 times the number of $6 tickets, that should tell me how much, it should equal up to the $3,580 that they sold the tickets for. Okay. And that brings us to step 3, is to decide which method for solving a system would be best applied to the problem and then carry out that method. So we're going to go back and look at our 2 equations here, and we're going to decide which method we want to go with. Now, to be perfectly honest, substitution, elimination, in this particular case, it doesn't matter. Just pick one and go for it. I'm going to go with substitution. So I like that first equation, that x plus y. I can easily get a variable by itself there. So speaking of which, I'm going to star this. If x plus y equals 525, then what does y equal? That would be 525 minus x. Okay, so then in going back to step 3, deciding the method, since I'm doing substitution, then I'm just going to copy this equation down. So 8x plus 6y, 8x plus 6 times y, because I found a new way to write y in terms of x, equals 3,580. Now, I'm already looking at these numbers thinking, yeah, I probably want to have a calculator handy. Alright, so then in the blank, I want to rewrite 525 minus x. Okay, so now we're going to distribute and combine like terms and see what happens. And okay, so 8x plus, and I'm just going to go straight to the calculator and say 6 times 525 gives me 3,150. Minus 6x is 3,580. All right, let's see, I can see some like terms here with the 8x and the 6x. So that's 2x plus 3,150 equals 3,580. I'm going to subtract the 3,150 from both sides. So I get 2x, and again I'm going to go straight to the calculator for this. Minus 3,150, it's 430. All right, divide both sides by 2, and I get that x equals 215. And again, I want to find y as well, so I'll go back up there. Y is 525 minus x. So y is 525 minus x. So in this case, 525 minus the 215. And I get that y happens to be 310. Okay, so that brings us to the next step. Step 4 is to check your solution. Okay, so we kind of already used this x, y, x. I'm going to go back. I'm going to show you what I'm talking about here. Looking at the two equations, I leaned heavily on x plus y equals 525 to get my two numbers. So if I want to really honestly check it, I'm going to go with the other equation that I did use at the start, but I haven't used it in a while. It would be the 8x plus 6y equals 3580. And technically it should work in both. Okay, so the question is 8 times 310 plus 6 times 215, does that in fact equal 3580? So if I type that in a calculator, I get 2480 plus 1290 and if I add those two numbers together, 2480 plus 12, let me make sure my math is right. Hopefully you caught the mistake that I caught. Did you figure out what I did wrong? Let me show you in case you didn't catch it. I got my numbers switched. Because when I checked it, it didn't work out right. We'll pretend that that was on purpose to see if the class was paying attention. But considering you're watching this at home, no, I goofed. I made a mistake. X is 215, so 8 times 215 plus 6 times 310. Okay, so let's see if that checks. 8 times 215 is 1720, and 6 times 310 is 1860. And so now let's add up, and that does in fact equal 3580. Yay! All right, and then last step is to write your final answer in verbal form. Okay, let me kind of do just a sort of a thought experiment with you real quick. So if I asked you, hey, I know how much money we made last night. How many tickets? How many different, what would the sales receipts say for the number of $8 tickets and $6 tickets? And I come back and I say something like, well, 215, 310. Did I actually answer your question? So if I give you an ordered pair, when I asked you how many $8 tickets did we sell, and you answer back with some sort of ordered pair that we can plot a point on a graph with, did you really answer my question, or did you say something kind of weird related to the actual numbers? And it looks kind of weird, So generally, if you get asked something verbally, you want to answer something verbally. So all I would need to do then is say, well, there were 215 $8 tickets and 310 $6 tickets. And I've actually answered the question. You asked me how many of each type there were, and I've given you a sentence that says how many of each type there were. All right, the very last concept in this particular section deals with the fact that what if we have, I mean, two variables is fine. We have a lot of tricks up our sleeve for that one. But what if we have more than two variables? In this case, what if we have three variables? So I'm gonna go through this example with you, but I want you to appreciate while we're doing it that it's complicated. There's a lot of steps involved, and there's a lot of things that you got to keep track of while you're working out the mathematics. And honestly, I'm showing this to you so that when we get to the next lesson and we learn this whole other type of way to do this particular type of problem, that you appreciate the simplicity of the other method. So in other words, I'm trying to scare you so that when we get to the other skill that I would really expect you to use, you appreciate it more as compared to having to do it this way. So the first thing I'm going to do is I'm going to label, because it's going to be really easy to lose track of these things. I'm going to label each of these three equations as 1, 2, and 3. Pretty obvious which one is 1, which one's 2, which one's 3. And then I'm going to group them together in pairs of 2. And I'll need to do this twice. And again, you'll see why here in a second. But I'm going to look at 1 and 2 together. So 2x plus y plus z equals 4, and negative 3x plus 2y minus 2z equals negative 10. Okay, now before I make any decision about what to do, let me take a look at all three equations together and sort of see if I can make a long-term decision. What I'd like to do is I'd like to eliminate one of my variables from everything. And once I got one variable eliminated, I'll have it down to a two-variable equation, in which case the stuff we've been practicing will be relevant. Now, in looking at all of my things, I see the x's, say 2x, negative 3x, and x. So it's possible I could eliminate x's. I'd have to multiply by different things to get rid of stuff. The y's, say y, 2y, and negative 2y. Well, those bottom two equations are already set up to cancel out the y's. And as far as y and 2y, if I just multiply that y by negative 2, then that should cancel it out. Well, that's actually not that bad. But again, look at the z's. Maybe the z's are better. So the z's, I have negative 2z and 3z. Well, that's kind of like the x's. They're kind of all different numbers. So I'd have to multiply by different things for each equation. Looks like the easiest variable for me to eliminate right now are the y's. So that's what I'm going to do. And so I need to multiply this, what I'd say the top equation, by negative 2, and that will allow the y variables to eventually cancel out. So let's multiply that out. So I get negative 4x minus 2y minus 2z equals negative 8. And then we'll bring over, sorry, that's supposed to be an equal sign. Bring over the bottom equation. So negative 3x plus 2y minus 2z equals negative 10. Okay, so from here, I want to add the two equations together. And that gives me negative 7x. The y's cancel out, which is what I was shooting for. That's why I made that choice. Negative 2z and negative 2z is minus 4z. And negative 8 and negative 10 is negative 18. Okay, so that's not too bad. Now I'm going to put a little star next to this. And again, I'm doing that so I can keep track of all of these little things that I've got going on. And now I'm going to partner up equation 2 with equation 3. So negative 3x plus 2y minus 2z equals negative 10. And here we get x minus 2y plus 3z equals 7. Okay, now I've already got the numbers in front of the y's are already set up to handle canceling out the y's. So I can do that. All right, so what do we got here? We got negative 3x and x, so that's negative 2x when I add them. Y's cancel out, plus z equals negative 3. Okay, I'm not going to star that. So what I want to do next, now I've got my 3 variable equations down to 2 variables. I want to partner up the 2 starred equations, and then I want to use my skills from earlier in the section, so the things we've been doing for a while here. So negative 7x minus 4z equals negative 18, negative 2x plus z equals negative 3. Okay, so now I get to decide what I want to do. If I want to go elimination, substitution, I see that if I multiply this bottom equation by 4, that'll allow the z's to cancel out. All right, so let's do that. Let me kind of scroll this over here. All right, so that would be negative 8x minus 4z equals negative 12. And I'll just bring over that negative 7x. So negative 7x minus, I'm sorry, let me double check my math on that. Should be plus 4z, shouldn't it? Okay, everything else is good. Okay, so I just got excited about that negative. Minus 4z equals negative 18. All right, and then when I add the 2 equations together, I get negative 15x equals negative 30. Ooh, I see this one. So we get x is, set that up there. So x is 2. All right, so we got one letter down. Yay. Okay, so now what I'm going to do is I'm going to go back in and find z. All right, so let's find that. Like I got to draw a little border here so I don't get these things too confusing here. All right, so let's take that bottom equation. The bottom equation says negative 2x plus z equals negative 3. Well, now I know that x is 2. So negative 2 times 2 plus z equals negative 3. Okay, so I can kind of quickly solve for z then. So negative 2 times 2 is negative 4. Oh, too far, too far. And so we're going to add 4 to both sides. So I get z equals 1. Okay, so far we got 2 of our letters. Okay, so now what I want to do is I'm just going to go back up and pick an equation. The 2x plus y plus z equals 4. Just kind of pick one. And let's fill in what I know, and then I can solve for y. So 2 times x plus y plus z in this case is 1. Y we got was 2. Sorry, x was 2. All right, so multiply that out. So we got 4 plus y plus 1 equals 4. Y plus 5 equals 4. So y equals negative 1. Okay, so let's collect up all of our letters here. So we got x was 2, we got y was negative 1, and we got z was 1. Okay, again, it should be x, y, and z, just alphabetically. Doesn't matter, it's not important the order we solved it in. That doesn't tell me what the answer is. But that does tell me that x, y, z, so which one comes first, which one comes second. All right, and then it's always a good idea to check it. Now you could go in and check it on all 3. We kind of used one equation to find it. Let's see, so 2. So let's do that bottom one. So x is 2 minus 2 times 1 plus 3 times, let's make sure I get my numbers right here. Negative 1, negative 1 and 1, okay. So negative 1 and 1 And is that actually going to give us 7? All right, so 2 plus -2 times -1 is +2 plus 3, and yeah, that does in fact give us 7. Okay, so all of our evidence points that we actually did that right. Yay. So there's our final answer is 2, -1, 1. Now, that's complicated. There's a lot of steps involved, but if you're organized and do it one step at a time, you'll get there. It just takes patience and practice, mostly patience, some practice, but a lot of patience. So good luck.